I won't record it. It's not material that will be on the final, but I will talk about the Android vulnerabilities, which I cannot release publicly yet, but I'll talk about them here. I'm planning to propose a talk to DEF CON about it today or tomorrow. I don't know if they'll approve it, but anyway, you'll get a chance to see it if you want. It's not required for the course or anything. And after that, I'll go up to the lab, and on the last day, I'll just have an open lab. Anybody can do projects to catch up. But I won't add any more lectures because the textbook, there's enough material here. So, yeah, final exam is on paper. Short answer, not multiple choice. So it'll be a question, and you have to write a sentence for an answer. And we'll have it here, and it covers all 13 chapters.
How does the scores work? The points at the end?
Let's take a look. Okay, the scores. If you go here, you'll see the scores. Here's the quizzes you took. Here's the required projects. Here's all the extra credit projects. And the final exam is in there. It just adds up to a total. If your total gets high enough, you get a good grade. Just if 594 or more, you get an A. A bunch of people already have an A. You do not need to take the final if you have enough points to get whatever score you want. If you don't take the final, this will just be 0, and you'll get whatever score is calculated from that number of points. So all these people in green can leave and do nothing further, and they still have an A. They've made it up to the bar. Everybody's welcome to take the final if you just like to complete things, you're interested. I didn't find final exams to be a very valuable part of my experience as a student, so I kind of de-emphasized them. I've got it there. It's a requirement of the college, and that's one way to go. But most people would rather do more hands-on projects than take the final. That's a popular alternative, which is fine with me. As long as you're learning to do something, I'm happy. If your real goal is to pass a certification exam, like the Certified Ethical Hacker, that would be a reason probably to take the final. Then you're going to focus on the tests and textbook part of it. But if you don't care about that, then the hands-on part is enough. Anyway, so that's important. I know some people do require the final somehow. I don't. It's just points like anything else. It's 80 points. So doing 4 or 5 projects is as good as the final as far as I'm concerned. Any other questions? You're good. There are always people with concerns about the administrative stuff at this point, which is understandable. So here's the last bit, network protection systems. There are a lot of devices on your network that control and limit attacks, and they control and limit traffic. So the idea is, first you have routers, and these are like traffic signals and lanes that just control which way the traffic flows, and that actually has a large effect on your security. One of the very common security mistakes made by companies, for example, several certificate authorities got hacked, and it turned out that they had flat networks. This is when you just have no network segmentation at all, no traffic control at all. You just have one gateway, and once you're in, all the machines are just one hop away, or on the same layer 2 network. This is a way you set up like a home network where you only have a few machines, but it's a very bad way to set up a business because you cannot have any defense in depth. You can't have some zone that's untrusted and some zone that's trusted and some zone that's restricted, and you should be able to do that. So the first thing you have to do is use routers to divide your network into regions. So you have different layers of security. Then you have firewalls that block obviously dangerous packets, and then you have intrusion detection systems that analyze traffic in much more detail to remove dangerous traffic from the network. And then you may have honeypots, which are there to confuse and distract attackers. Not that common in small networks, but various versions of them have been proposed to protect all sorts of networks, but I think only the largest companies are actually using them at this point. Anyway, so routers are the things that control normal traffic on your network. So you have traffic for some region and traffic for another region. So you have traffic on this network here, 192.168.0, and this one here is the 190 has a different, so they've subnetted it, I guess. Oh, this has local network, this has local network, and they substituted here. Anyway, you break up networks into categories. There are subnets, usually the first 3 numbers in the address determine the subnet, and you have to move through a router to get lifted from one network onto another. Each of these is connected by a switch, so all these computers can talk to each other right away, but if they want to talk to some computer in another network segment, they have to be lifted off this network by the router and moved onto another network, and the router has an opportunity to control that. So that's a hardware device. This is at the layer 3 of the OSI model. It moves, the point of routers is to move packets to the correct geographical location. So your IP address says where you are in the world, like your zip code. Now, the original routers back decades ago were very primitive, very simple devices, and you would just have to program each one of them manually. So you'd have to tell each router what network it's connected to, and that's what you do typically at your home network. But when you have more complicated networks and they change more often, then you have routers that automatically tell each other what the traffic is there. So if you have an internet service provider and you branch out to another city and open an office in that city, and now some of your traffic has another route to get places, it will just tell the other routers on the network what's there. This is sort of nuts, but this is the way the internet works. You mix control traffic with data traffic and routers. Routers tell you have one, so the same line that is carrying customer data carries special messages at one of these protocols that tells the router to reconfigure itself. So there's linked state routing protocols are where every router has complete information about the network, like OSPF, which is a modern high quality routing protocol that works very well. But in the early days, the first routing protocol was RIP, which was very simple and very primitive and caused a lot of problems. But the advantage of it was it could run on really old, weak hardware. And so routing information, RIP, is when routers do not even know the structure of the network. All they know is I have 3 ports, this port, 3 hops to China, this port, 2 hops to New York, this port, 1 hop to San Francisco. That's all they know, is which direction and how many hops. They don't really know the path anything's taking. And then there's the backbone of the internet that moves data across from cities and nations to other places, to each other, is governed by Border Gateway Protocol. And this is very complicated, very few people are qualified to operate it, and when you make mistakes in Border Gateway Protocol, you foul up traffic for the whole world. If you make mistakes on the other protocols, you only foul up traffic within your own company. Yeah?
What's the internet backbone? Okay.
The internet backbone is the tier 1 ISPs, like Sprint and AT&T, that carry major traffic over major hops. There's a lot of regional ISPs that maybe provide traffic inside one city, but they just lease bandwidth from a tier 1 provider. The tier 1 providers are the people actually own the real hardware that goes large distances, primarily long fiber optic lines underground.
Was AT&T the original?
Originally, the internet was a non-profit research project that you could not do business on. And in, I think, 1993, the National Science Foundation sold it to 4 telephone companies. And they put the United States into 4 regions, approximately like time zones, and they sold it to them. And AT&T was one of the original 4, and I think so was PacBell. And they owned it. Then the internet was now a commercial project owned by the internet service providers, which were also the telephone companies, and they then leased out access to it as part of your phone bill, and now it was legal to run businesses over it. And that was what started the World Wide Web. The internet was around before then for email and for network enthusiasts to use for sort of a hobbyist basis, but it didn't become a commercial property until then. And then they made the graphical browsers and the World Wide Web where you could now distribute pictures and videos and stuff, which was all done to facilitate business. Anyway, that's a good question. That's where you are now. They own it, just like they own the phone network.
So is Comcast the one that's putting in the fiber optics?
Yes, Comcast traffic is going through fiber optics. And I don't think Comcast is a tier 1 service provider, but I'm not sure. If you can be a tier 2 or a tier 3, and what that means is you provide service to people and you lay some cables, but you don't really have connections that go to other cities and nations. You just lease from somebody like AT&T to use their cables. And the same thing's true of telephone services. There are local telephone services, but if you make a long distance call, they have to pass that traffic on to another provider, and they have to negotiate a deal with that provider. That's called a peering agreement, to say, how much are you going to charge me for letting my customers use that line? And what they all try to do is to get cost-free peering agreements where they make a deal. You'll let my customers use your lines. In return, I'll let my customers receive traffic from other people on your lines, and we'll all get along that way. And sometimes the ISPs go for that, and sometimes they don't. There was a huge peering dispute in the IPv6 backbone, which at last I heard had still not been resolved. The IPv6 backbone does not actually go to everybody because 2 major providers can't negotiate a service agreement. So those customers can't talk to each other. It's analogous to the national highway system in America. It's put up there by somebody and everybody uses it. As I mentioned before, Border Gateway Protocol is old and very insecure. There are no passwords, there is no cryptography. You can send a BGP message. Now, you can't send one from your computer. If you send a BGP message from your computer, your ISP will refuse to forward it because you're not supposed to be using BGP on your home network, and they know that you have no business doing it. The only people that can do it are people at large companies and internet service providers that have direct contact to the backbone. And the last I heard, there are now 2 million administrators in a position like that. And every one of them can send any BGP packet at all. There is no control. So I can be in San Francisco and go into an ISP's office, and I can send a packet telling it to reroute traffic in China, and it will just do it. Because there is no password or authorization or verification of anything. So this has been used as a weapon repeatedly. China has done it several times in the United States. It's widely regarded as the test of a military weapon. They send packets that reroute American traffic to briefly go through China in the middle. So you try to go from San Francisco to Mountain View to read your Gmail, and for a half hour, that all goes through Shanghai and back. And that puts them in the middle because they can reroute the traffic. All they do is they send a false BGP update that says, I have a faster route to Google going through here. And it will just believe it and do it, even when it's obviously not the faster route, because there's no testing, no verification, no sanity checks. It just takes the message. Now, what happens is, if you left it on for a day or two, everybody would catch on. They'd say, why is my Gmail so slow? They'd start tracking it. People would notice. But if you do it for about a half hour, it's over before anybody notices, and you can intercept traffic for that period of time. Now, if you had HTTPS sites, you would think the certificate authority would tell you that, because you can't do a man in the middle on an HTTPS connection. Because the person in the middle, now you can get in the middle of just moving the traffic, like the router at your coffee house is in the middle between you and Gmail, but they can't read any of it because it's got an encryption key that came from Google. So to get any good out of this, you have to send a false certificate from the man in the middle, claiming that I'm Google, use this key, and then they can decrypt it there and re-encrypt it and send it to Google. And that should fail because your browser should warn you that you're not certificate is not signed by a trusted certificate authority, but the government of China is a trusted certificate authority, and your browser will not warn you. That's because if they didn't do that, all the Chinese websites would all have errors, because they're also signed appropriately by that. So there's a lot of talk. The two fixes for this that are in their infancy now are HSTS pinning, where you put a flag on your website telling people this should be secure, and you should remember the first time you connect, what the certificate authority is, and warn the customer if it changes. And also certificate pinning in applications on your phone, which is possible, although I'm not aware of any any app that actually does it, where they program in your browser the name of the certificate authority in your app, so it will not accept any other, or Chrome, which memorizes who the certificate authority should be for, I think, the top 1,000 websites. The Chrome browser will warn you for popular websites if this kind of attack is in progress. But nation states can just totally do this, and anybody else with enough money to bribe a certificate authority into giving them a root certificate, so they have a trusted root certificate, they can put themselves in the middle, and corporations and law enforcement officials do it all the time. Just like they man in the middle of your telephone conversations with little vans with stingrays in them, they man in the middle of your internet connections, and this came out because of the Suits and Spooks conference. It was made up by, it was going on for 2 or 3 years, where the spies come and meet the other security professionals. It's organized by Jeffrey Carr, that gave a talk here about international spying a couple weeks ago. And they sell hardware for companies to use to man in the middle HTTPS connections, so they can read all the supposedly secure connections at their company, and for law enforcement to buy. And it just has a USB slot and it says putting the certificate here. So they have some way to get it. And there's no official authorized or reasonable way to get that. It's not, I don't know if it's exactly illegal, but it certainly violates the trust model of the internet. But the existence of this hardware implies that it happens all the time, and that's another of the open secrets. You know, before 2010, when Google admitted the Chinese hacked them, it was an open secret since about 2003 that everybody in the business knew that China was hacking everybody, but nobody would openly admit it. And so in the same spirit, we all know that this is going on too, that everybody is getting fake certificate authority certificates and silently man in the middle your content. And it's the way it is. Since there are no laws in this space, no rules, no government agencies, no licenses, it is just whatever people will put up with. And the people who write browsers are mostly commercial entities that do whatever they want, except Mozilla. Mozilla is sort of a club. Everybody votes in the forums, and they did try to throw TrustWave out. When TrustWave admitted that they had been selling their certificate authority certificates to the highest bidder, and they announced, we have now decided this is immoral and we quit, Then they said, you bums are going to throw you out. They said, you didn't listen. You should leave us in and throw everybody else out because everybody else is still doing it. But we're the ones that quit. But just like the NSA saying they're not going to read your email anymore, this is another claim that we can't verify. Yeah.
Who else has been doing this besides China?
Well, China does it frequently. Done it several times and got caught. There are also a lot of mistakes happen on the internet. Czechoslovakia made a bunch of defective routers. Well, they set up some advanced routers that sent long BGP chains that crashed about 15% of the old routers on the backbone, so they snarled up traffic for about a day on the whole internet when they turn those things on. It's also, Pakistan has done it a few times. So, 2 or 3 times there's been a video appearing on YouTube that insulted Mohammed, and the Pakistan government ordered their government internet service provider to get rid of that video, and they made mistakes when they did that. They black holed YouTube, so they claimed they had, the way you black hole something is you set your router to say, I have a really fast route to get to YouTube, just one hop. So all the traffic will try to go to the fastest route, and you send it to a machine that just throws it away. That's called black holing something, where you get rid of all its traffic. And they did that, but they forgot to block BGP updates. So they advertised to the entire internet this super fast route to YouTube, so YouTube went down. For a whole hour, YouTube was down, whole thing, and people call up Google, the servers are up, the internet is up. They tried pinging it, why is our traffic going to Pakistan and never coming back? So when they found out, since there is no governing body, there's just a body of, sort of a club of engineers that run the backbone, and when you do something that irritates them, they punish you at their discretion. So when they figured out that it was Pakistan putting out bad BGP updates, killing YouTube, they punished Pakistan by blocking all routes to Pakistan for a day, so they lost the internet. Until they turned it off, and that was the end of that. And you would like to think there's like a fine or a rule or some kind of qualification exam to say you're qualified to make this traffic, and there's none of that. There's just a community of network administrators in like an IRC forum that decide what to do about the backbone. The college, someone in this room, a few years ago sent out SNMP updates for one of these machines, and we didn't know it, but we got contacted by our internet service provider at I think our tier 1. They said, if you idiots don't firewall your network, we're going to just turn off the college's internet and have good luck teaching classes then. So that's what we did. We put on a firewall and filtered the traffic better now, so you can't send bad things from the lab. But you'd like to think there's a rule telling us to do it, some court, some way to sue. There's none of that. The internet is just a free-for-all ruled by a bunch of guys that are just sort of a club. Yeah?
Do you have any idea where the school has it set in your administrative settings or possibly firewall settings where you can't use proxy or VPNs while you're in class?
I know the people that run the college network, and I'm not quite sure why they did that. It is annoying. I think what they're worried about is that bots use those. So they're worried that a machine will be infected on campus and be used to send spam. So, and also, I know there's only like 4 people administering the whole network, so I'm pretty sure what they did was just turn on some standard security package, like recommended for schools or something. And it's just getting updates. If you have a layer 7 firewall, it's Palo Alto. You can do anything with those, but it's a lot of work. And there's nobody here to do that work, so I think they just tied us up for a standard filtering package. It's a big issue on campus. I know another issue is blocking porn. Some people wanted to block porn on campus, but there are human sexuality classes and art classes on campus where people are looking at stuff that some people consider porn as part of the class, so we can't really block it, and these issues go around and around. Yeah?
It's not blocked in the library.
No, I don't think it's blocked anywhere on campus because we're all adults here. That's the idea.
I mean, San Francisco Public Library.
What's that?
Oh, yeah, that's not.
It's not blocked in the San Francisco Library.
Oh, it's not blocked in San Francisco? I'm surprised.
No, I don't know. I'm asking.
Oh, I think it probably is. I think most high schools and grade schools and public buildings like libraries do have to block it because people will complain of their children going in there, and that's what gets people mad. At the college, everybody's supposed to be an adult, so it's not, I think, as big an issue. But certainly, that's the problem with the internet. No matter who you are, there's stuff on the internet that will offend you. Everybody is mad about some of it, but they don't agree on what to be mad about. In Thailand, you can't insult the king. In Pakistan, you can't install Allah. In America, you can't make a copy of a movie or a video or a music when it's distributed. Everybody has a bunch of stuff that they hate and they're trying to block, but they don't agree on it. You had some?
I just wanted to ask if North Korea ever did something.
North Korea is essentially not on the internet at all. Very few people have it.
3 websites.
They have, and also North Korea has their own operating system, which they brought out, and it has leaked out, and I've seen it in hacking competitions called Red Star OS. It is like Ubuntu Linux, but it includes a bunch of government spying. So that's the idea. So if you use a computer in North Korea, you are supposed to use their official OS, which reports everything you do back to the government. It's also fantastically sloppy and insecure. It's in the hacking contest, we're hacking into it, and it's pretty appallingly bad. But what I've been told from what little information does come out of North Korea is almost nobody there has a computer at all, just like the top government officials. It's sort of like contraband. Because their entire social system relies on no one finding out the truth about the outside world. I mean, they have to believe that it's just horrible out here. By comparison to them, that's what they're told. Anyway, so there's a lot of these. There's been a lot of tracks. Here's another man in the middle attack showing that somebody in Mexico was trying to get to Washington, D.C., and for some unknown reason, it all had to go through Moscow and back on the way to Washington, D.C., so they're doing it too. Lots of people are man-in-the-middling things on a global scale. And you can, since there is no actual official monitoring or limits or rules or anything, you can get away with it until somebody notices. So if you do something like kill YouTube for the whole planet, you'll get caught. But if you move the traffic from one city through another city for half an hour, nobody will notice. In fact, at DEF CON, about 6 years ago, there was a hole in the schedule on the last day. There was a student, and he noticed there must be a talk that they didn't tell us about, and he went in there, and that was the talk where two New York City researchers explained that they had rerouted the entire traffic from DEF CON through New York City and collected it all for the entire conference, and no one noticed, 3 days. And they were presenting the results of analyzing that traffic. So, you can do it for a while, and if you're a little bit careful, people won't notice until it's all over, and maybe not then. So that's the game. You can also do IP hijacking versus BGP, like pirate radio. You can take an IP address that is a public IP address that some other company has bought, but they are not using, and you can send BGP updates saying, I've got a server on that IP address, send it here, and you can just keep using it, and nobody will notice or care until that company uses the IP address. You might get away with it for years, just like you can put up a radio transmitter and run unapproved radio stations, and you're okay until somebody notices and complains. If your power is not too big, it might work. It's all illegal, but you can get away with it for a while. So you can go to see routing histories. The Backbone, here's one of them. These are, the companies have autonomous system numbers. Every ISP has one, every big company has one. That determines your network. And as far as the Backbone is concerned, they just have to get it to your network, like the post office. The post office does not deliver mail to buildings and rooms here. They just have one receiving station where they just bring in a big box of mail and dump it. Okay, you guys sort it. And that's the way the internet service providers are. We have one point of presence where the internet traffic comes in, and then once it enters that point, the Border Gateway Patrol and the Backbone washes their hands of it, and now it is your job with your internal routers and switches to separate out all this traffic. So as far as they're concerned, you're an autonomous system. As long as I get it anywhere inside the Sprint network, it's delivered. Now Sprint will take it from here. These are what the routers look like, these rack-mounted devices. These are the classic Cisco routers. This is what runs almost all the Backbone traffic on the internet. It's just racks and racks of these things with cables and power supplies moving this traffic around. So Cisco routers, there are other brands now, but Cisco is the big player. If you are a big internet service provider and you have a lot of traffic to move, Cisco is alone. Cisco is the only supplier for top-end high-volume traffic, like terabits per second. At the lower end, like small and medium business, there's a bunch of players, but at the big end, Cisco stands alone. And it's a computer with no hard drive, but it has an operating system and it has vulnerabilities, and you can hack Cisco routers. But there's never been a mass hack or a spreading virus of Cisco routers because they are so disorganized, they are secure through chaos. Their operating system is called iOS with a capital I, and there are 250,000 versions of iOS in the wild. If you have a problem with your Cisco router, you pay for a maintenance contract, and they will alter your operating system to fix it. So now yours is different than every other one. And the next time you call, they will find the engineer that fixed it last time and go to that person's computer and modify it again. So every one of the OS is like individually customized, like a handmade wooden desk, which is crazy. But it does mean that you can't make a spreading virus because they're all different. It's also wasting a lot of money inside Cisco. Their company is very old, their policies are very old, and they had a new engineer come in about 4 years ago that said, I'm going to clean this up and have like version 11 and then version 12. And all the hackers at DEF CON said, man, if you do that, I'm taking over the whole internet the day after that happens. And they never did it yet, as far as I know. It's very strange, but that's because it started when the internet was very small and they had all these procedures. And the reason Juniper exists is because Cisco would not update their internal policies. People got very, very frustrated being inside Cisco using all these archaic techniques, and finally formed a competing company called Juniper to do it better, because this operating system called iOS is very strange, very old, very primitive, and hard to use and hard to expand. And they said, forget it, just use Unix. Most other routers just run BSD Unix, and that's what Junipers do. Yeah.
Cisco has the Nexus 8000 series.
What's that? Yeah.
Nexus,
Nexus 8000? Yeah.
yeah, which is their beefy, really powerful. Just curious, will you ever hack into that?
I've never heard of a big hack of the big ones, although certainly it could happen, because that's why their internal engineers get frustrated. They're keeping really old stuff. Like this iOS stuff is sort of like MS-DOS. You can take a class here and learn it. It's a very valuable thing to learn how to program these Cisco routers. It's not very difficult. It's like just a couple of pages of plain text to program a router. It's just funny little language. It looks a little bit like Linux, but it's not. And so the router doesn't have any hard drive. It just has non-volatile RAM, where they actually get 16 kilobyte memory chips. I don't even know how you could get these without going to a dump and digging up technology from the 70s. But they actually have 16 kilobyte chips that are remembering the configuration table. And then they have a flash memory, like in a flash drive, that has a compressed version of the OS. So when you boot it up, it takes 2 or 3 minutes to unzip the OS and put it in RAM. And then it reads the configuration table from this NVRAM, and then it's ready to go. And packets come in, they wait in the buffer in RAM, it sends them out. If anything happens at all, there's no exception handling in this operating system. If it tries to divide by 0 or anything, it's an illegal instruction. The whole router just reboots, throws away all the traffic, reboots, and starts moving traffic again, because the point of it is it's supposed to just stay up. And even if something's wrong, if the power goes out, if there's a defect in the code, it just restarts and keeps going. It doesn't matter if it drops a few packets. What matters is to keep it moving. So these things, like I said, when the Czechoslovakia put out routers that sent out border gateway protocol updates that the older Cisco routers could not handle, for an entire day, the effect was internet traffic was just terrible. The routers would come up, they'd start sending traffic, then they would crash as soon as they got an update from Czechoslovakia, go down, then they would come up 2 minutes later and take traffic again, so you'd be sending traffic to them, then sending traffic away from them, then sending traffic to them, then sending traffic away from them, because they're fault tolerant. Their fault tolerance is to just restart after every error and try again. And that's why so many companies have these things in a closet and no one has looked at them in 10 years. Somebody programmed them 10 years ago and they're still working. They'll keep working pretty much forever until the hardware dies completely. And that's what they're for. But that means people had no idea how old and vulnerable they were, because nobody even knew what you're using. Anyway, flash memory has the iOS in a zip file, which it unzips and loads, or some kind of compressed file. And then it has read-only memory, so that if you completely corrupt the operating system, which can happen, it can boot in a minimal emergency mode that you can use to rebuild the router configuration. And you'll learn to do all that if you take the Cisco classes here, which I highly recommend. It's a very good thing. If you want a job, get a CCNA. It's one of the main certifications in this business. You get a Microsoft certification to be a Microsoft systems engineer, or you get something like Red Hat certification to be a Linux systems engineer, or you get a CCNA to be a Cisco engineer, and those are the people that keep every company running. Somebody has to run the servers, and somebody has to run the routers. Those are steady networking jobs. So you got interfaces. You'll have Ethernet ports and serial ports and other ports that are plugged into the router. And the iOS looks sort of like this, with simple commands like host name and version, interface, IP address, and so on. You just learn these commands and program them in, and a simple text file like that configures all the interfaces, giving them all IP addresses, and configures the routing table, telling it what traffic to send this way and what traffic to send that way. Your home router, like your Linksys or Cisco or whatever you've got, Linksys or Belkin or something, is just a very miniaturized version of the same thing. Routers can filter traffic. They just do it with IP access lists. So they just take a packet and you can tell it what to do. Like here's where I'm going to tell it. This is going to deny traffic. I don't want traffic from network 3 over here, 173, to enter network 1. This is very common. I have a network like the internet, and it's coming into my company, and I don't want it going directly to the database server. I want it to go to the web server, and then the web server can talk to the database server, but nobody on the internet can talk directly to the database server. So you have rules like this. Any traffic from this network over this range of addresses, which means the last 2 digits can go from 0 to 255, deny that. So if anybody from here tries to address this router will just block the traffic. It's just like a gate or a red light on the road. It can look at the individual packets in a very simple way. You can look at source and destination IP address, the protocol type, or the port number, and you can say what traffic should go through and what traffic shouldn't. This is what the first firewalls did, generation 1. They just looked at this information in the header of the packet. Those firewalls are now essentially useless to block any real attacks because attacks are a lot smarter, but in the early days, people actually used goofy ports like 31337 for attack traffic, and if you blocked it on that port, you'd actually block attacks. So the first thing firewalls did was just use these simple rules. Just like the first spam filters would actually look for something like Viagra in the message, and pretty soon they learned to just misspell everything to get through that, and on it goes. So Michael Lin was a Cisco researcher. He was a contractor hired to examine the security of Cisco routers, and this is the story you'll hear over and over and over again. He found problems with Cisco routers, and he felt like management wasn't taking him seriously. This is what happens all the time. Security researchers freaking out say, they aren't fixing my problem fast enough, they don't understand how important this is, so he went public. Now he asked Cisco for permission to give a talk at DEF CON, and somebody said yes. And then a week before the talk, somebody in management found out, I think probably somebody in legal, and freaked out and said no, and they sent the FBI into Black Hat to impound all the DVDs before they handed them out to the customers showing up at the conference because they had the forbidden talk on it, and to stop his talk. So a few of those DVDs snuck out and people posted it in foreign countries. I found it in the Netherlands. And then he gave the talk anyway. He tried to give a talk about something else. The audience booed, and he said, oh, what the hell? And he gave the forbidden talk. So after that, his company had to fire him. Cisco threatened him with legal action. He could have been, he was like, he tried to claim he's a whistleblower or something. But what happened is nobody really pressed charges, and he got another job, and he got away with it pretty much. But he certainly did absolutely break the corridor with the FBI right there trying to stop him. It was, this kind of thing promotes DEF CON. That's why I started going to DEF CON. I heard about all this. I watched the talk and I said, man, I should be in on this stuff. There's important stuff happening over there, which there really is. And he had all the dirt. He had all the magic numbers to identify the Cisco operating system. He had the details of how to hack it. It was very interesting stuff. And I've been told it all got patched, of course, because after that, Cisco said, well, I guess we'll pay attention to this after all. You know, that's one thing about this public shaming. It does motivate people to change, but they don't thank you for it. Anyway, so got a few iClicker questions. Grab one if you need one. And that's why the talk I'll give next week is what I hope to give at DEF CON. And right now, these companies have not had their 30 days to ignore me. By the time of DEF CON, they will, and I'll feel justified in just publicly shaming them. But right now, I'm not going to. I'm waiting in a futile effort to get them to change. It's very clear that they're all just ignoring me, but you know, it's like a pro forma activity. Like when you have a wedding and they say, does anybody have an objection to this wedding? There has to be a moment where you wait as if anybody cares, and then you just do the dirt. Anyway, so. All right. All right, so what operating system do Cisco routers use? All right, I guess I'll quit at 30, see how many there are. All right, and that's iOS with a capital I. Apple used iOS with a small I. I guess I don't know if they had a lawsuit over that. I think the word, and Junos is what Juniper routers use, and it's based on BSD Unix, and man, it is so much nicer. Anyway, so much easier. You know, if you forget the password to a Cisco router, what you have to do is beyond belief. You have to get a computer that's at least 15 years old that has a hardwired 9-pin serial port, and you have to connect to the serial port on the router. These things are extinct, but you have to find them. Then you have to boot the router up, and you press like escape B or some crazy control function to boot it into a special mode, and then you type in these binary machine language looking commands to reset the password. So somebody donated a Juniper router to the lab, and I booted up, it asked for the password. I said, holy crap. I have to reset the password. You know, on a Juniper router, there's just a red button in the back, just like your home router. You just push in the button, and it resets it back to factory defaults. And I did that, and you know, Cisco could have done that. But they just think it's still 1970, which is why Juniper exists. It's very frustrating to work there. You say, why are we doing this the old way when there is such a better new way? And that's the difference between iOS and Junos. But Cisco owns the market. They're the standard. They have the best classes. They persist, even though they do everything really old-fashioned. Anyway, All right. So which device is at layer 2? I'll quit at 25. All right, that's switches. Switches are at layer 2 of the OSI model. Routers are layer 3. If you take Cisco, you really learn this stuff. If you take Net Plus, you get your first pass through it. And it is important. The first 4 layers really matter. 5, 6, and 7 in reality are pretty much blurred together, but the first 4 really matter. And you can see them in Wireshark and everything. If you want to pass any CompTIA exam, you've got to know the OSI model, among other things. Anyway, all right. So where is the iOS stored when the power goes off? Because there is no hard drive, which is the first thing that surprised me when I started learning about routers. All right, I'll quit at 30. All right, it's stored in flash. NVRAM would make sense, except the NVRAM is incredibly too small. It's only 16 kilobytes, which is mind-boggling. It stores in flash memory like what you find on a flash USB stick. And it is so slow that it takes them like 2 or 3 minutes to boot up. Anyway. All right, so what's the memory structure that's easiest to exploit for overflow vulnerabilities? We've talked about this in previous chapters. This was a big deal of that Michael Lynn talk. He talked about what kind of overflows you can use on Cisco routers. I'll quit at 30. All right, and the classic kind of overflow is a stack buffer overflow. It's the easiest to exploit. I haven't talked about it much in this class. This is somewhat cruel. That's why the iClickers are extra credit. They're not entirely fair. We're doing this in the exploit development class. You start with stack buffer overflows. It is very easy because there are variables in the stack, and if you can write past the end of a variable, there's an address on the stack that is used to return after the function is over. So it's very easy to just hit an address that immediately takes over the program, giving you control of the instruction pointer. Other overflows are more difficult because even though you get a chance to write to some unexpected part of memory, there isn't anything there that directly goes in the instruction pointer. So you have to make a more complicated exploit to take over the machine. That's why I think I mentioned a student who just released a new iPhone jailbreak, which is awesome. And that entire project, I give him all credit in the whole class just for doing that, of course, so that's awesome. And he found a vulnerability in the iPhone that let him write 1 byte of 0 to a memory location, and that's all it did. And he figured out how to take it over with that, which is pretty awesome, because that's like your only tool is a banana. Now do something, fix this car, you know. Anyway, it's a very weak attack can work if you are very clever at exploiting it. But most of us need like a stacker overflow so we can get to the EIP to take over a box. Anyway, so what protocol selects routes on the backbone? All right, I'll quit at 30. All right, that's BGP, Border Gateway Protocol. I know a guy, Ed Horley. He's the second guy in charge of Pacific IT Pros, the user group. He is an expert in BGP. And companies pay him as a consultant and they fly him in to fix their BGP because it's hard to do. And when it's wrong, it fouls up everything. Cloudflare went down for half an hour from a bad BGP update. Rerouted all the traffic to all Cloudflare servers to the wrong place for half an hour before they figured it out. You can trash your entire company with one mistake in BGP, of course. So it's super important.
I heard from
Carlos, did he do BGP?
He messed up one of these big projects.
Oh, yeah. Oh, if you foul it up, it's complicated. It's easy to foul up, and it's super critical. All traffic in and out of your whole company depends on this being right. Yeah, you can totally bring down the whole company with it. That's why they pay you big bucks if you learn it. You can't learn it here. You need to get a CCNA, and then you need to go beyond it and take more advanced classes, which we don't offer here. But you'd start by getting a CCNA, and then go to some place where you can take those advanced classes and learn BGP, and then you're one of the ninjas of the internet, you know. Yeah. It would be one of the CCNP classes. There's a CCNA, which is the first 4 classes, and then there's things beyond that are called CCNP classes. There's like one in security, so it's one of those advanced classes, and I've never had it. What's that? I don't know. They keep changing it, and I'm not up on the latest stuff. There used to be quite a few different ones. It's not a straight line anymore. After that, you have the basics, and you can go in different directions.
Would doing Juniper be the same thing?
I do not know what the Juniper setup is. I think Juniper routers do handle BGP, and they have some classes. I only have the first Juniper certification, which is Junos as a second language, which is like half like the CCENT. They have more Juniper certifications after that, though. So both Juniper and Cisco have cert classes, and you know, I wonder if I can find out. It's good enough to spend a minute checking. Let's get Cisco BGP certification, because it's certainly a good thing to have. And here we go. These guys will teach it to you. CCIP, apparently, yeah. So that's a new one to me, but apparently, there you go. CCIP means you know BGP and MPLS, and here's the exams. So it looks like, here's the BGP class, and I guess there's 4 classes to become a CCIP. So it's up there. Like I know CCIE is the top security one in Cisco, and those guys, there aren't very many of them. They're highly sought after. These are advanced things beyond what you get at this college that would definitely move you forward. But by the time you're getting this, you've hopefully got a job and your boss is paying for it. Because these classes are typically, you know, like the boot camp, 1 week, $5,000 class stuff. There's not enough people at these advanced levels to teach it at this kind of place where we have to fill the room. You'll have a class of, you know, 6 people that paid $5,000 each to go there or something. And their boss paid for it, obviously. Anyway, good. I'm glad you bring it up. So, all right. So which one of these cannot restrict traffic in a router access control list? I'm going to quit at 30. All right. You can't use the URL. That's layer 7. The rest of these are layer 3 and 4. It can do that, but the URL is layer 7. That's called deep packet inspection, and only layer 7 firewalls, which are the modern kind, can do that. Routers don't look at that part of the packet at all. It's just like the post office. They don't open the envelope. They just look at the address on the front and move it along. They pay no attention to what's inside. That's not their purpose. And so if you want to do something like block Facebook, the only thing you could do is block the IP address range that leads to Facebook, like Pakistan did to get rid of YouTube. You can't actually look in the packet for Facebook.com and block the ones that have Facebook.com in them. So if Facebook has another proxy somewhere that's serving up their content, you won't get it. And that's how people get around high school filters that try to block traffic to things they don't like games and stuff. You just go to an unexpected IP address, and those primitive defenses can't stop it. That's why people pay for layer 7 firewalls like Palo Alto's. They look at the structure of the packet. We block BitTorrent, and it looks at the structure of the packet to see, is this a BitTorrent type packet, regardless of the IP address and the port number, and they block it. So no matter, you can't get BitTorrent past it, at least not easily. Anyway, so we ought to take a break till 10 after 10. Then we'll carry on here, and I'll stop this video. This is chapter 13. This one, okay. 123, 13A.